Hi, in this video we'll be looking at prime numbers and we'll be focusing on prime factorizations and also how we can use those prime factorizations to find the least common multiple and the greatest common factor of two numbers. Okay, so let's get started. Let's look at some counting numbers greater than 1. So let's say 2. So from 2 to 12. So let's now discuss the factors of these numbers. So let's take a number like, say, 6. What are the factors of 6? Well, the factors of 6 are the numbers that can divide perfectly into 6. So of course, there is always the number 1 and the number itself, 6. What would be some other factors? Well, then you'd also have what? 2 goes into 6 perfectly, and 3 also goes into 6 perfectly. We could take another number like 10, and of course 1 goes into 10 times, and 10 goes into 10 one time. So every one of these numbers can be divided by 1 and by itself. However, as we see here, these two can be divided by 1 itself, and then you have other factors that divide into it perfectly. So in this case we have 2 and 5. However, if we take a number like, say, 7, 7 will only have the number 1 and itself as factors. There is no other integer that divides evenly into 7. So let's take the number 2. The same thing, the number 1 and the number itself. So you could go through each one of these and you'd see then that some numbers would have only 2 factors, the number 1 and itself, and other numbers would have more than 2 factors. Those, like in this case 6 and 10, are called composite numbers, and the ones that only have 2 factors, 1 and itself, are referred to as prime numbers. So here the prime numbers are, let's just look in this little list there. The prime numbers would be 2, 3, 5, 7, and 11. And the composite numbers would be the numbers 4, 6, 8, 9, 10, and 12. So all counting numbers can be divided into these two groups, prime numbers and composite numbers. Be careful that here we see that this prime number is even. So 2 is the only even prime number. All right. Let's say we have the number 24. We could write this 24 as 2 times 3 times 4. 2 times 3, 6 times 4, 24. This is a factorization. We could also say 2 times 2 times 6. This would also be a factorization. However, note that in none of these cases do we have all the factors being prime numbers. So a prime factorization is a factorization in which all the factors are prime numbers. We could say 2 times 2 times 2 times 3. Note in this case, the factorization is made up only of prime numbers. So this is called a prime factorization. And a prime factorization is unique. There's no other way to get a prime factorization. There's no other combination of numbers. So what we'll look at next then is how we go about getting this prime factorization. You could just do it like this. You could just say, well, 24, that's 2 times 2 times 6, and then look for the prime factors in here. Okay, so let's look at that. To get the prime factorization of 24, we simply start off like this. We say 24, and then we get 2 factors, and this one is 2, and that's going to be 2 and 12. And then you identify your prime factor by placing a circle around it. Now you can put a check mark or something else, but let's put a circle. And of course we continue here. This becomes 2 times 6, and of course here we have another prime number, and this becomes 2 and 3, and of course both of these are prime. And so our prime factorization then becomes what? 2 times 2 times 2 times 3, which of course we already knew. Of course we could simplify this by saying 2 to the third power times 3, right? So this is our prime factorization. We could do this for other numbers. Let's say a number like, say, let's say 48. This becomes 2 times 24. And of course, then from this point on, it's the same thing here. Now, but let's just do it again. Let's do 12. Remember, circle these. So that becomes 2, 6. And this becomes 2, 3. And so now this becomes 2 to the fourth power times 3. Suppose you're given the numbers, let's say 6 and 14, and asked to find the least common multiple of these two numbers. Well, one way to do this would be to find the multiples of both of them, and then look for the smallest one. So let's do that. So what I have here is a little Excel spreadsheet, or the results, of some calculations I did on an Excel spreadsheet. And so I have the numbers 6 and 14, and I find the multiples. So what's the multiple of a number? It's the result of multiplying that number by some counting number. So here I'm multiplying 6 by 1, then by 2, then by 3. Notice 1 times 6, 2 times 6. So this number here is 7 times 6, 42, and so on. And so these are the multiples of 6, and these are the multiples of 14. Of course, this goes on forever. I stopped at 22. So let's look for the common multiples. So the common multiples would be, let's look here. If we start off, there's a 12 here, none over here, 18 here, none over here. And I can continue coming down until I see, okay, here I have a 42. So I'll just put a check mark here. Put a little check mark here and a check mark here. That's one common multiple, right? And then let's coming down some more. We have 48. There's no 48 over here. 60, no 60 over here. 72, none. If we look, we see at 84, and yes. So just so I don't, I can identify them quickly, I'll just use a different. So here I'll just use this little. I'll just use a little symbol like that. Right. So I know these two go together, right? And do I have any more? 890. We come looking down. 108. 120, 126. Good. See another one here. I'll just make a little box. 126. So if you have two numbers, I believe you can imagine, you can see that this intuitively, that there will be an infinite number of common multiples, right? I can keep on going on, and I'll find more multiples in common. But we want the smallest one. And of course, if I look at all these common multiples that I have so far, I have 42, 84, and 126. The smallest one is 42. All right, so now you should understand what a multiple is, and you should understand what we're talking about when we refer to the least common multiple. Now what we want to do is find a better way of determining that least common multiple, which I'll simply refer to as the LCM from this point forward. And so the method that will be used to find the LCM is going to be the prime factors method. And it simply consists of finding the prime factors and then moving on from there. So we already know how to find the prime factors of a number, so I won't go into that again. You can just go back a little bit in this video and look at that if you need to. The prime factorization of 6 is 2 and 2 times 3. And the prime factorization of 14 is 2 times 7. And so the LCM is going to be a number that is a multiple of both of these, and obviously the smallest number that is a multiple of both of these. And so let's just start with this one. The LCM has to be something that can be divided by 2 times 3. So let's just put 2 times 3 here. I'll just use a little dot here. All right. However, can this number 14 be divided by this? No, right? Because a multiple of 14 has to have 14 in it. You know, it has to be divisible by 14. Well, I can fix that easily by simply placing a 7 here. So let's take a closer look at this, because it's not, the point of this is not so much that you are able to find the LCM. You can just Google that or something. It's about understanding the ideas and the principles that are going on here and having a deeper understanding of just what the LCM is. Notice I can look at this number here and look at this now as what? 7 times 2 times 3, right? So obviously this is a multiple of 6. It's 7 times 6, which is 42. But I can also look at this as 3 times 2 times 7, right? Obviously this is a multiple of 14. It's 3 times 14, which is also 42. And this then is going to be our least common multiple. We can put more prime numbers here, I guess, and find other multiples, right? I can put another 2 here, right? Which would then bring us up to 84, right? And so on, right? Or I could put a 3 here, which would then bring us to 126, right? But this is the least, right? So let's hope you understand this, right? Let's do another example. Let's find the LCM of 12 and 18. So this can be written as 2 squared times 3. That's the prime factorization. And this can be written as 2 times 3 squared. All right. So now the LCM has to be a number that has that is divisible by both of these. So it has to be divisible by 12, let's say, right? So the LCM, and this is not complete yet, I haven't finished, I'm just beginning it, right? So I can just say 2 squared times 3, right? And of course then this number here is, well, 12, so it's a multiple of 12. I could multiply this by 2, by 3, by 4, and all the results I get would be multiples. But I want one that's also divisible by 18. So is this number divisible by 18? No. It has a 2 here, but it's missing another 3 here, right? So I need to place another 3 here. All right. So notice I have 2 ways of looking at this number now. Then I can look at this number as, and I'm just explaining this. You don't necessarily need to go through all these steps. Just make sure you understand the idea. This number is what? 3 times 2 squared times 3, obviously. So that's 3 times 12, which is 36. But I can also look at this number as 2 times 2 times 3 squared. Right, see, right? 3 times 3, 3 squared. There is 2 here. And so this becomes 2 times what? 18, because this is the 18 here, right? And so that's our LCM. So let's just summarize this then. So the LCM of those two numbers then is going to be 2 squared times 3 squared, which is then just 36. Let's do one more. Let's suppose we are now asked to find the LCM of 40 and 60. So that's 40. And let's just get the prime factorization one time. That's going to be 2 to the third power times 5. So again, we have looked at this before, so make sure you go over that and know how to do this. And the prime factorization of 60 is 2 squared times 3 times 5. So by now then it should be easy for you to see that the LCM here then will simply be what? 2 cubed, alright, times 3 times 5, which gives us 120. So this is very easy once you get the prime factorizations. Note, just go over this again. This is a factor, this is a multiple of 40 and a multiple of 60. It's a multiple of 40 because I can look at this as 3 times 2 cubed times 5, notice. And it's a multiple of 60 because I can look at this as 2 times 2 squared times 3 times 5. So obviously this is 60, as we see here, and this is 40. Now let's look at finding the greatest common factor. And so let's start with an example. Let's suppose we want to find the greatest common factor of the numbers 12 and 18. So let's put the 12 here and 18 here. Well, one way to do this would be to just find the factors of 12 and 18. And so the factors of 12 are 1, 2, 3, 4, 6, and of course 12. And then 18, the common factors, the factors are 1, 2, 3, 6, 9, and 18. And so we look for the common factors. So we have a 1 here and a 1 here, we have a 2 here and a 2 here, we have a 3 here and a 3 here. 4 isn't common, and so we have a 6 and a 6. And so these are the greatest, right? This is the greatest common factor. So what's a factor? Remember, a factor is, the factor of a number is a number that divides evenly into it. And so these are the factors of 12, these are the factors of 18, and the greatest common, because notice we have many that are common. We have 1 is common, 2 is common, 3 is common, 6 is common. Of the common factors, 6 is the greatest. By the way, we have factors that are not common, 4 and 9, obviously. So now what we want to do is find a way to do this using prime factorization. So the prime factorization of 12, again, go back and look at how we do this if you don't remember, is 2 squared times 3, and the prime factorization of 18 is 2 times 3 squared. And the GCF then, we find this easily now by simply looking for the greatest common prime factors, right? So the greatest common prime factors here are 2. Notice not 2 squared because there's no 2 squared here, but 2 is here, obviously, right? There's a 2 times a 2. So that's 2, and there's a 3 here and a 3 squared. So the greatest common factor is 3. So that gives us 6. And so it's very easy once you have the prime factorization to find then the greatest common factor. Let's do this for another pair of numbers. Let's do this, let's say, for 60 and 40. So if I have the number 40, the prime factorization of 40 is 2 cubed times 5, and the prime factorization of 60 is 2 squared times 3 times 5. Let's be consistent here. And so what's going to be the greatest common factor now? Well, the greatest common factor is going to be 2 squared. Let me make this a little bit neater. I apologize for that. So that's going to be 2 squared. So hope you see that, right? 2 squared is the greatest multiple of 2 that goes into both 2 squared and 2 cubed. And then what else do we have in common? 3 is not common, right? So that's not a common factor. And of course then we have 5, which gives us then 20. Okay, so that brings us to the end of this video. If you take classes with me, we'll go over these things in class with some more examples. Okay, so bye for now.